Hello everyone, in this video let's discuss about how to design 1:2 DEMUX or demultiplexer. If you are new to our channel, please subscribe for more engineering related topics. As we proceed in all the videos, let's proceed with the 4 steps. That is, first step will be drawing their block diagram. Next, using the block diagram, we can represent them in the truth table. Next, using the truth table, we will write the equations. Using the equations, we will be writing the circuit or logic diagram. Now, let's follow these 4 steps. So, the first step is writing the block diagram. So if we see the question only, what is it? 1:2 demultiplexer. 1 represents the input and 2 represents the output. So therefore in DEMUX 1:2 DEMUX we will be having 1 input with 2 outputs. So in the block diagram we will just represent the inputs and outputs. What are my inputs and what are my outputs? So this is 1:2 DEMUX. Next, I will call my input as I and I will call my output as y0 and y1. So I got my inputs and outputs depicted in the block diagram. Now I continue with the truth table using this block diagram. If you see the block diagram, what are my inputs and what are my outputs? My input is only one, that is I. My outputs are y0 and y1. But I cannot take this I as an input because this input will be going to the output, that is y0 or y1, which will be decided by the selective lines. So we must find out how many number of selective lines are required. So if we see what is the number of output, that is 2. So how can we depict 2 in 2 powers? 2 power 1 will be 2. If it was 1:4 DEMUX, it will be 2 power 2, that is 4. 4 outputs will be there, no? So 2 selective lines were required if it was 1:4 DEMUX. Now we are building the 1:2 DEMUX, so 1 number of selective lines is required. So I will call that selective lines as S0, and we will also use another one input, that is enable. Whenever the value of the input is 0, we cannot proceed with any of the process. We can proceed with the processes only if enable value is equal to 1. Therefore, what will be my inputs? S0 and enable. So my inputs are enable and S0. So now I have 2 inputs. If I have 2 inputs, what will be my combinations? My combinations will be 0, 0, 0, 1, 1, 0 and 1, 1. So now using this combination, I had earlierly told that if enable value is equal to 0, no operations will be processed. That is, no output you can get. Therefore, both y0 and y1 value equal to 0. Now if enable value is equal to 1 and S0 value is equal to 1, let us assume that the input will come out as output through the y0. So I will put I for y0. Input will come out as output now. So next, if E value is 1, that is enable value is 1 and S0 value is 1, I will assume that it will come through the output y1. Now using this truth table, we must design the equations. So we must design the equations for the outputs. So how we will design? What are my 2 outputs? y0 and y1. So for y0 column, where I value is there? Here. So what is the value of E? What is the values? E, S0. S0 value is 0. So I will put S0 bar I. And what is for y1? E, S0 and I. So these are the characteristic equation. Now using these equations, we will be building the circuit diagram. So what are my inputs in the circuit diagram? enable S0 and I. Enable I and S0. So S0 bar is also there. So S0 bar means we will use the NOT gate. Now for first one, that is Y0, enable S0 and I. So this will be combined using the AND gate, because in between there is no plus symbol, it means multiplication. Next for Y1, enable S0 and I. We will combine them using AND gate. So this is the circuit diagram of the 1:2 DEMUX. So we completed the block diagram, truth table, characteristic equation, and the circuit or the logic diagram of 1:2 DEMUX. Hope you understood the concept of 1:2 DEMUX. If you like the video, please subscribe for more engineering content. If you have any doubt, please comment below. Thank you.